Okay, this is for the first part of the section on ellipses and circles. Okay, we've already talked about parabolas. Let's take a look at ellipses. We're going to have two axes. This long axis is called the major axis. And the small axis is called the minor axis. The point where they intersect is your center. Now this thing actually has 4 vertices. These are the 2 main vertices are off of the major axis, and then these 2. Okay, the length of the major axis is 2a. In other words, the distance from the center here out to this vertex is a. And the length of the entire axis is 2a, because this is in the center. And b is the distance from the center to this vertex, so the length of the minor axis equals to 2b. Okay. Now, an ellipse has 2 foci. If any of you have ever been in a whispering gallery, you should have bumped into this. These are your foci. What happens here is that if someone is whispering something here, if you have a reflective surface, you can hear it very clearly over here and vice versa. Anything someone is whispering here, people over here can also hear it very well. So this is a focus. This is a focus. Each ellipse has 2. And in plural, they're called foci. And the distance from the center to each focus is called c. All right, there's our basic vocabulary. Equations for ellipses. I've got a horizontal elongation. In other words, my major axis is horizontal. Oh, by the way, A is always bigger than B. Because A is your major axis. Now, if A equals B, you've got a circle. A equals B equals the radius. Okay. Anyway, for horizontal elongation. A couple important things to know. These equal to 1. If it's horizontal, my bigger number is going to be under the x. And my vertices here are going to be at plus or minus a 0, it can be reduced to plus or minus b 0, reduced to, these would be my vertices. My foci is at plus or minus c and 0. Okay, now c is related to A and B by the following equation. This is very important to know. And this does come from Pythagorean identity, Pythagorean theorem. If you go in and you draw in these things, what you will find is that you do have some right triangles, but I'm not going to spend the time to do this for you. Okay, So that's for horizontal elongation. For vertical, in other words, my major axis doesn't look like this. Now it looks like this, where my major axis is vertical. Again, a couple things, it's equal to 1, and my larger number now is under y. Okay. My vertices here are going to be at 0, plus or minus a. 0, excuse me. I think I screwed up on this one right here. This one should be 0 plus or minus b, because the minor will be in the y direction. And these are all assuming that your center is at the origin. So 0 plus or minus a. The second one is going to be plus or minus b, 0, for your vertices. And my foci is going to be at 0 plus or minus c. Will be my foci. Okay. Another term I want to introduce to you is a thing called eccentricity. Which is now out around the ellipse is. You can also look at this as how far away from a circle it is. So if it's a circle, then the eccentricity is 0. If it's a line, then it's 1. So the eccentricity for these is going to be bigger than 0, but less than 1. And the formula, remember, C is the distance from the center to a foci, and A is the distance from the center to a vertex on your major axis. Okay. Let's work some examples. They want you to sketch a graph of this one, which is x squared over 16. So the first thing to check, is that equal what? Yes. Bigger one is under x. This is going to be horizontally focused. Remember, this is a squared. So a is going to be the square root of that. Part of the square root is 4. P is 2. So now, our vertices are going to be there, there, and there. You can draw a sketch like that. Okay, to find my foci, C is going to be the square root of a squared, excuse me, b squared minus a squared. I think I told you wrong before. It is b squared minus a squared. Now wait. If you look it up in your book, this is 10.2. I think I wrote this one off. C squared equals the square root of a squared minus b squared. I had it right to begin with. And this has to be the way it is because I want this to be a positive number. Okay. So what I do is C is going to be the square root of 16 minus 4, here's a squared, here's b squared. So c is going to be equal to square root of 12, which will be 2 square roots of 3. So I want to be out here somewhere are going to be my foci. And to get the eccentricity of this thing, it'll be 2 square roots of 3 over a, which is 4, will be the square root of 3 over 2. Will be your eccentricity. Okay. Let's do another example. So we're finding everything, including graphing. Now the first thing you notice about this one versus the other one is this does not equal 6. Equal 1. It's 36. So what you do is you divide everything by 36. 9x squared. And that makes it equal to 1. Then I simplify here. X squared over 4 plus, and I simplify here. Notice how bigger number is here. This thing will be elongated vertically. A is 2, B is 3. It's going to look like C is going to equal to the square root of, B is 2, A is 3. A is always a bigger number. B is 2 and A is 3. Okay, and this 4, 3 squared minus 2 squared, which is going to be the square root of 5. Going to be a little more than 2. There are my 2 foci. Eccentricity is going to be the square root of 5 over A, which is 3. Okay, one more. On this one, what you're given is that the foci are at 0, that's minus 3. And I've got a vertex. This will be the major vertex, 0 plus or minus 5. Now you notice both of these are along the y and the y-axis, so this thing is going to be elongated horizontally. Okay? So we know we're going to have to go five and 5 this way, but we don't have a B. All we've got is an A. Okay, but that's not a problem because this is C. So what you remember is that C squared equals A squared minus B squared. We're going to solve for B squared. Or B squared equals A squared minus C squared. So what we do now is we plug these numbers in. B squared. So A squared will be 25. C squared, C squared is going to be 9. So B squared equals 16. Or B is 4. Now we can write our equation. Since it's this way, my A goes under my x term. So I'm going to have x squared over B squared plus y squared over A squared equals 1. The eccentricity of this thing is going to be 3/5 C over